So this is the International Math Olympiad 2024 question 6. For all x and y from the real numbers, there's a function from the reals to the reals that states f of x plus fy is equal to f of x plus y, or f of x plus y is equal to x plus fy. So there exists a c in the positive integers, such as the Aquilinian function that stated above states that there are at most c different rational numbers in f of r plus f of minus r, and we are asked to find the maximum of c. I don't know why I put minimum. It's supposed to be maximum. So for putting x equals 0, we can use f composite 2 of y is equal to f of 0 plus y, and f of 0 plus y is equal to f of y anyways. We can just do the similar and make it an x, and we can also show that so and so here. I thought that this would be an okay method, but there should be a far better method to do it. So instead, I decided to go down this route. Afterwards. So we say that there's f2 of x is equal to f of 0 plus x, and f2 of x is probably going to be x plus c, where c is f of 0. And fx is probably going to be fx, f of minus 1 of x plus c. So when we input 0, f minus 1 of 0 is supposed to be 0. Before I did so, I thought that this would be a really mid proof, so I decided to go even further. So this is the original statement, but I put the functions as simulated to a and b, and we are trying to and by putting 0 as b or a, or we could put 0 for any value of a or b, we can prove that f inverse minus 1 of 0 is 0. So afterwards, I decided to state that first of all, f of a is equal to f minus 1 of a plus f of 0. So as a result, I decided to say f of 0 is going to be constant for f of 0 is going to be a constant for all a. So we put f of a minus f minus 1 of a is equal to f of a plus 1 minus f1 of a plus 1, which is going to be a0. It's going to be f of 0 anyways. So by subtracting and adding all over again, we can show that we can assume that first of all, the first statement in here, we can assume that this one is only true. And we try to do so. However, when we allow for a and a plus 1, we allow for the first statement to be realized. And when we input it back into the original equation here, as you can see right here, you can get the function f of a plus b is equal to f minus 1 of a plus f of b is equal to f of minus 1b plus f of a, which assumes that both statements, both are true, and this is also true. As you can see, this and this is true, as long as this and this is also true. So therefore, since we already know that, we can even go as far as to say this. That since f of a plus b is already defined anyways, we can already plug in the values of r and minus r, which make it f of 0 anyways. Since f of 0 is equal to f minus 1 of r plus f minus r is equal to f minus 1 of minus r plus f of r, we might as well just already be able to say that f of 0 is equal to 0, because when we apply the function of the applied f of f minus 1 is 0, we already know that's going to be f of 0 anyways, and that's already going to be 0 in the first place, right? So as a result of all of this, we can lead to the fact that f of minus 1 of r is equal to negative f of r, such that f minus 1 of x is equal to f minus f of minus x. So the inverse is basically the definition of the odd function. So we get two realizations. First of all, that f of x plus f0 is going to be is going to be f of x or f of x, so that f of 0 is probably going to be a constant c. So we can say that f of x is equal to f of x, or we can have this, such that f of x plus 0 is going to be f of x plus f of 0, or we can assume f of 0 is 0, or for some constant c. So therefore, we can make the solutions Cauchy. Oh, wait a minute, this is some horrible idea. I'm here. So we can make the solutions Cauchy. So as from the Cauchy equation, we can see already right here, we already said that f2 of x is already equal to x. f2 of x is already equal to x, as by the second definition right here. So we can therefore say that f of minus 1 of x is probably going to be f of x. So therefore we try to solve the Cauchy functional equation that f of a plus b is equal to f of a plus f of b. One of these functions was the inverse. So since the inverse is the function itself, we can just assume Cauchy functions. And afterwards you can get the function, you could get the function f of x is equal to kx plus c, where for this instance k is equal to 1 because first of all our function would therefore be odd, and c is probably going to be f of 0. So as we can say, if c is equal to 0 as we stated, f of x is already equal to x then. So, and since this function is probably strongly increasing, we can see f of x is equal to x, and f of r plus f of minus r is equal to r plus minus r, which is equal to 0. So therefore, one of the values is 0. However, since we assume that c is the constant of f0, we can also assume f of r is equal to r plus c and minus r plus c, which added equals 2c. Thus, there are only 2 values of c at the maximum. Thank you for coming to my Math Olympiad channel. I hope you subscribe, and thanks for watching. Bye.